Alrighty. Good afternoon, everyone. My name is Estevan Munguia. I'm a student at the University of Arizona in the MS-GIS program, and I'm also an intern at Tucson Water in the GIS section. And today I have a presentation for you, creating a web GIS solution for GPSing Tucson water meters. So on the agenda for today, I'm going to discuss the background and motivation for why I created this solution. Then I'll quickly discuss the workflow that I use in creating the solution. Then I'll demonstrate my apps and do a few live demos. And then I'll finish with a conclusion. So at Tucson Water in the GIS section, we maintain a database of all of the water infrastructure in our service area. These range from service lines, water mains, valves, fire hydrants, etc. But for the vast majority of these, we don't have accurate information as to their locations out in the real world. These are based on old documents and paper maps that were later digitized. What I'm showing here is our water meters layer as it exists in our database currently. There's about 250,000 of these in our service area, but for most of these, we don't have very accurate locations. They're off by 30 feet, 40 feet, maybe even more in some instances. And this presents a challenge whenever we need to do any kind of maintenance, if we need to inspect them, or if we need to replace some component of the water meter, because what happens over time is that they get covered up by vegetation or dirt or rocks. And then the people that are out there working in the field looking for these, they have to start digging up people's properties to actually find the water meter. And it's a time-consuming process, and it's not good for the property owner as well. So just to prove my point further, I'm going to show a few photographs. So this picture I took back in March or April of this year. It's near the Catalina foothills. And this water meter in particular took 4 people 20 hours to find. I was out with some guys and they were trying to show me some of the challenges that they have in finding water meters. And if you look here in the background, you can sort of see what the issue was. So all this brush, vegetation, dirt, and rocks, this was all covering up the water meter, so it was invisible to them. And it took them 20 hours to find. When they did finally find it, they put these rocks on the perimeter so that they wouldn't have any more issues finding it in the future. So this next picture is also a photo of a water meter. This is one I took back in June. You probably can't see the water meter. It's actually right here. The only reason that I knew that it was here was because I noticed this black hole right in the middle. And this is where you would actually stick your tool in to pry open the water lid. And I have a short little clip that shows somebody doing just that. So you just stick your tool in there, steel rod, and then you just kind of bang on it until it flies open. But you can see it's invisible. It's concealed perfectly with all this other gravel, and it's very hard to find. And this is an issue that comes up a lot out in the field. They have these kind of issues all the time, and they're spending a lot of time and energy finding these water meters out in the field. So it definitely is a problem. And what can we do about making it easier for these guys? So we can actually use some technology that we have in-house at Tucson Water. So we have these receivers here that we can use to geocode the features using GPS technology. So what this actually is here is a Trimble R2 GNSS receiver, so Global Navigation Satellite System. That is combined with correction services, and we need correction services to get the accuracy within 12 inches, which is what the threshold was, the requirement was for Tucson Water. We used real-time kinematics for this project. The way that works is you have a base station at a known fixed location, and then you have a bunch of rover receivers like this one here that actually go out and do the data collection. And then the base station sends corrections to all the rovers to get that accuracy within 12 inches. All of that is combined with Esri software, in particular field maps for the data collection. And I'll talk more about field maps in just a minute. As far as data collection is concerned, Tucson Water hired a bunch of high school interns for the summer as part of a internship project being hosted by Pima County. So they were the ones out there doing the data collection. I was out there supervising them along with some other Tucson Water employees. So this is the workflow that I used in creating the solution. First, I added GPS metadata fields to our existing non-GPS layer. So that's the layer of the map that I was showing you before. Basically, I just added lat, long, altitude, accuracy, and other GPS metadata fields. I published that layer to the City of Tucson's ArcGIS online site, and I created a web map from that layer. Then I customized a form for field maps collection. Basically, I just added a bunch of questions. Then I created a desktop app using Experience Builder, and that includes some tables and some filter widgets. Then I built a dashboard, which includes gauges, charts, and indicators. And then finally, I developed an App Studio mobile app for finding meters out in the field. So I'm going to talk about each one of these, starting with the web map. So this is the web map that I created. It's fairly simple. It just has a layer of the water meters. It's symbolized by service subtype. So for water meters, we have different subtypes. We have your regular water services. We have irrigation services. Critical customers would be like a hospital or a clinic, something like that. And so they're color coded by that. They're also labeled by meter numbers. So these purple numbers that you see here, each are the meter numbers. And it just makes it easier to find for a particular meter. If you're looking for one in particular, you can find them easily that way. You'll also notice that some of these have white dots at their center. And if you look at the legend, it tells you what that is. It's the ones that were GPS. So this summer, we mostly GPSed around the University of Arizona. And what this is actually is another copy of the water meter layer, but symbolized with a white dot and filtered only to show the ones that were GPS. And the way that this is done is through an SQL statement. So when a feature gets GPS, a field in the metadata gets auto-populated with the receiver name, and then I'm just filtering to show those that were GPS. So that's the way that that works. So next up is Field Maps. So Field Maps is the app that you would actually use for the data collection process. So the way that this works is you would Bluetooth connect your tablet with the GPS receiver. And once that connection is made, you would go to your tablet and open up Field Maps, which is this app right here. And here you would go to My App, Water Meter GPS Map, the one I just showed previously. You would navigate to that one. And the way that this works out in the field is you'd walk up to a water meter, open it up with your tool, look at the meter number, and then find it here on the map. And it's easy because they're all labeled by the meter number. If you can't find it right away, you can search for it using this little magnifying glass here. Once you find it, you go ahead and click on it. It'll open up a window here. And then you'll want to go to the little pencil icon on the bottom left, click on that. And that goes into the edit mode where you actually do your data entry. So here, the first thing you'd want to do is actually update the point. So the way you do that is you go up to the top right, click on that little arrow, and then it moves these crosshairs from where it was previously, which was here on this icon that I had clicked. It'll move it to my current location, this is where I was when I was recording this video. Notice that the accuracy right now is off. It's 19 feet. Our requirement is 12 inches. And that's why you see this red lettering here and this button turned red. That's because the accuracy is not under 12 inches. It's not meeting our requirements. And that's only because I was using my iPad as the receiver rather than the actual GPS receiver that I showed previously. I'll just ignore that for now. I'll hit update point. I'll ignore that warning. And now you see it moved that point from where I was before over here to where I was when I was recording this video. Next up, you can attach photos or take photos, and we were asking the interns to take photos of the water meter just for future reference. After that, you can answer a few questions. So if the meter number was incorrect from what it says in our data, you can toggle that on and off. Is meter concealed? Is meter damaged? If you are unable to find the meter, and then an additional notes section at the bottom. Once you're done with all that, you go ahead and submit it on this upper right. And that's it, basically. It submits, it updates the web map and the underlying layer behind that in real time. So next up is the desktop app. This was created using Experience Builder. And this is what you would normally use to actually view the data. You wouldn't use the web map, you would use this desktop app, which has a lot more features. So you have a table here that gives you a tabular view of the data. So you have all of the fields that came with the defaults layer, and then also the GPS fields that I added in Pro before I published it. So all that metadata is there as well. You can search for a particular meter by the meter number or by the asset ID, which we call Synergen ID. We also have a number of filters up here on the right. So if you want to look at the meters that were GPS, you can toggle this one on and it'll filter to show only the ones that were GPS. So as you can see, as I mentioned before, we GPS mostly around the University of Arizona, but eventually we will do the entire service area. You can do the non-GPS, the ones that we were not able to find out in the field, damaged, concealed, incorrect meter number. Let me click on that one. And then it'll show the meters that we found that didn't match our data. So you can toggle these on and off. Okay, so moving on. Next is the dashboard. So this dashboard just gives a high-level overview of how the project is going overall. It's made more for upper management to see what's going on. So first of all, there's a gauge here that gives you the total amount of meters that have been GPS up until that date. So up until now, there's been almost 4,300 meters GPS out of about 250,000 of them. So we're just starting really. A couple of indicators that tell you the amount of incorrect meter numbers that were found, unable to locate meters, almost 200, and then a couple of pie charts that show concealed meters and damaged meters respectively in terms of percentage and also the raw counts down here. And all this data is coming from field maps. Whenever we're answering those questions in field maps, once we hit submit, this dashboard, as well as the Experience Builder app, that gets updated automatically in real time. So they're all these apps are talking to each other. And then finally, we have the App Studio mobile app. So I created this for field workers. When they're out in the field, they're not going to have laptops with them or computers. They're going to have tablets or iPhones. And so I wanted something for them to be to work in the field when they're finding meters. So this was created with App Studio Player. It's this purple icon here. So you would just go ahead and click on that one. And then in here, you navigate to my specific app, which is called Water Meter GPS Project Mobile App. So you'd want to find that one. And it's the same app as before. It's got the same basic layer of water meters. So you can filter by service subtype. So if you're looking for a specific meter subtype, you can just toggle those on and off. You can also search for particular water meters by the meter number or by the asset ID. So I have one here that I was searching for. Once you click on that, it'll pan and highlight that water meter. And then you can select it, tap on it, and it'll open up a window of all of the associated attributes with that water meter. There's also photo attachments for the photos that we took in field maps. That'll be on here as well. And we told the interns to take a couple of photos and have at least one photo with a landmark nearby. So in this case, like a bush or a gate. And this is just to give more context as to the location of the water meter. In case in the future, it's obvious where it is now, but in the future, it might get covered up. And besides the GPS location, we want to give more context as to where the water meter is. It's next to this bush, next to this gate, and that's just more information for the person looking for the water meter to make it as easy as possible for them. You can also click this little icon here. It'll drop a blue dot to show you your location relative to whichever water meter you're looking for. So that's the solution in a nutshell. Overall, I found the solution to be quite effective, easy to understand, easy to use, and it's accessible to all Tucson Water employees. And it'll help them in the future finding water meters. No longer will they have to dig up people's yards. They can just use the web map to find whichever meter they're looking for. And it can be scaled to other types of assets. So not just point features, it can be linear features as well. Service lines, water mains, we can do those as well. And that's something we might do in the future. It also has the potential of saving the city hundreds of thousands of dollars. Before, similar projects have been contracted out to outside companies and they charge us quite a bit. But if we do choose to do this internally, if we choose to continue it internally, then we stand to save quite a bit of money. And there's discussions whether we want to do it that way or not. They haven't decided yet. That's all I have really. I just want to quickly acknowledge all of the supervisors, but especially all of the high school interns who took part of this in this project. They were out there collecting the data in the middle of the summer. And as you guys know, this was a brutal summer, so it definitely was not easy. So I just want to quickly thank them and all the supervisors for all the hard work that they did.